So, hi everyone, it's Alvin's son here, and welcome back to week three's video. So, in this video, I'll be focusing on neural networks, um, backpropagation, and then LLMs, which just stand for short for large language models. So we previously discussed it in like past two videos how AI learns with using like neural networks, which it can mimic the human brain. The neural networks like contains an input layer, two hidden layers, and an output, and then each neuron in the networks is a um, function that process inputs and then pass them forward to layers and outputs. So the input is like the first layer that passes information towards the output, and then um, AI we improve AI by adjusting its weights and biases during like training, like gradient descent, like what I talked about in the last video. So actually, how do machine learns? The answer, like it's in neural networks, like the foundation of um, modern AI. The neural networks are like I just said, like neural networks are inspired by like how human brains works. So imagine how your brain tries to um, recognize an item. For example, like an apple. How do we tell an apple and an orange apart? So first of all, your brain will like an apple will be like input into your first layer of your brain, and then it moves to the hidden layer, and then output, which is supposed to be determined like what kind of thing, like if it's an apple or orange. Um, so maybe at first might like mistakes um a peach as an apple, but over time, once you like learn or look more and more different kinds of apples, you can tell them apart. So basically, AI is doing the same thing. So it learns um the patterns by adjusting like tiny calculation inside its network. A neural network is made of multiple layers or of artificial neurons, and then these neurons process like informations and pass it forward, just like a human brain would do. But like, how do they improve over time? Um, this is where like backpropagation comes in. So backpropagation is a algorithm that helps AI to learn from their mistakes. Like it calculates how off like the AI is to the answer, and then adjusts its internal rates using like gradient descent. Like this kind of process like repeated hundreds of millions of times until AI makes a accurate answer or prediction. So, but like, how do neural networks learn? Um, it's yeah, it all came down to like backpropagation, which um corrects like lets AI to correct itself and then get smarter and smarter over time. For example, like imagine like the past two video um I keep telling you guys like from the example from D3 to free blue one brown which is neural network trying to recognize a handwritten numbers. So first of all, it may like when it makes a guess, it may be seen like it's a 7, and everything is a 1. But I mean, like it um the neural network saw it's a 7, but turns out it's a 1. Since it's incorrect and then the error is calculated, the backpropagation helps adjust the connections into the networks to improve the accurate prediction. So backpropagation works like moving backward through the networks and then identifying which neurons makes the wrong mistakes. So if the output is incorrect and then it's start working back through the previous layer, adjusting weights and biases, and then um, gets the correct output using radian distance, and then repeat this repeat this steps over millions and millions of time, and then these small improvement adds up and then making the AI extremely accurate. So how really does like backpropagation works? As I mentioned before, like neural networks have three kinds of layers: input layers, inner layer, output layers. So when an input is passed through, but when the output is incorrect, the error difference will send back to the hidden layer and then backward through each neuron. Like a like a reading distance of error is calculated with respect to each weights, and then the output is like adjust to make more accurate prediction. Yeah. So like let me give you guys an example. Um like think of like when you're cooking, maybe a pasta dish. Like turns out your pasta dish comes out too salty, and then you just backtrack step by step and figure out which step do you put too much like salt. Is the cheese too salt? Is the sauce too salt? Or did you like over salt your pasta water? Yeah, so that's exactly what backpropagate does. It's like keep adjusting throughout the hidden layers, and then until the output layer is um, correct. So next up is LLM, which is um, the large language models. So how does like um, AI mix prediction with LLMs? Uh, which is um, a huge neural network trying to predict words like a language, large language models. They assign probabilities to like possible next words and adjust ways to um, improve over time. Um, like the training requires the training requires progressing a very large amount of text samples. So like when you a type a questions or like a sentence to a chat box, like AI, the AI doesn't like just like randomly responds. It's calculated the probabilities for the next word. What's the next word should be. So next, let's talk about transformers. Transformers is a older model that like read text one word at a time, which is very slow. So how do we can how can we make AI faster? The transformers analyze entire sequence at once using a attention mechanism, and this allows AI to understand the context better and makes faster and more accurate predictions. Like before transformers, our AI model used to progress text one word at a time, which is incredibly insignificant. Like in 2017, researchers at Google introduced transformers, which is a revolutionized AI that it can analyze entire sentence at once instead of like progressing one by one. So like so this helps like the AI understand the context better. Um, the attention mechanism allows the model to focus on the most important words. So therefore, transformers have made AI reading much smarter, more efficient, and faster. Allow modern AI to understand context and responds more accurately. But like AI, of course, is not perfect. It's only like good as its training data can, and it can still make tons of mistakes after like millions of time of backpropagation. Or there's a thing now we call the reinforced learning human feedback, which is a human feedback through reinforced learning. So it helps like refine AI responses. Like AI may seems to be super smart, but it have like major limitations. For example, like if you uh, show a bot a random image of digit, it will confidently set a random number, even though um it's not a number at all. Maybe it's like a English word like G, yeah, and then it may confidently say it's a 9. Why? Because like AI is trained to always give an answer, even though it's having like no clue what it is. It's just like recognizing the pattern. It's like having like students to do multiple choice quiz without studying. We can't answer anything, but it is a multiple choice, so I better give you an answer even though it's nonsense. So to fix this, AI go through another stage called um, reinforced learning with human feedback, RLHF, where human reviewer flag bad responses and then AI adjusted it's based on that feedback. So if you ask AI something that it's um nonsense or unusual, if gives you a confidence response but it's a wrong answer, then that's the sign that it's haven't been trained on that topic, that's specific sorry specific topic that you gave him. So even though AI learns through millions of billions of backpropagation cycles, it still make mistakes. Why? Which is why human feedback is needed um, to reveal or refine the predictions. So AI doesn't think like humans; it just predict words on probabilities. It learns from massive data sets, and then they improve through back propaganda, and then improve more using human feedback. Yep. So this is the topic that I want to talk today. Um, Thank you so much for listening, and then see you next week.